Hello, guys. It's freezing here in Sydney at the moment, but I'm quite warmed up and excited to share with you this new video where we will be fine tuning a model from scratch on our own data, and then we will put it onto the Ollama or export it to the Ollama. If you don't know what Ollama is one of the easiest and fastest tool to run large language models locally, and we have covered it a lot on the channel. Whereas we also have covered Unsloth. Unsloth is one of the how should I put it? One of the nicest tool or easiest tool to fine tune models or train models on your own local data. It tunes the model in extremely fastly with 80% less memory. You can even use this whole code on Google's Colab for free on T4 GPU. The speed will be a bit slow, but still can be used. But instead of that, I will be using a massed compute sponsored VM and GPU for this video. So if you're looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, you will also get a coupon code of 50% discount on the range of GPU, so do check them out. So without wasting any time, let's get started. We will be doing everything in our Jupyter notebook locally. I mean that we will be fine tuning a Llama 3 8 billion model on our own data. Plus then we will be exporting it to Ollama, which is already running locally on my system. So this is my Ubuntu system where I'm running Ubuntu 22.04 and I have one GPU card of 48 GB of VRAM NVIDIA RTX A6000. But for the purpose of this video, you don't need that much VRAM. You can replicate the steps on Google Colab T4 for free GPU, and I will drop the link to the all the code which I'm going to use in this video in video's description. So sit back, relax, just focus on what is happening, and then you can replicate it at your own leisure. Okay, so let me clear the screen. First up, let me create a conda environment which will keep everything separate in a virtual environment on my local system. Let me create it. I'm just calling it FT for fine tuning. You can call it whatever you like. Let's wait for it to get installed. That is done. Let me quickly install Torch because that is required. Let's wait for it to get installed. Torch is installed. Now let me install the Jupyter notebook and also launch it in the browser. Let's wait for it to get installed and launch. And the notebook is launched in the browser. Let's click on File, New and Notebook. Let's wait for it. And let me install some of the prerequisites. So you see that I am installing this Unsloth from the source. And then I'm also installing other libraries like parameter, efficient fine tuning, accelerate, and bits and bytes. Let's wait for it to get finished. Okay, so prerequisites are installed. Next up, let's import the thing which we have just installed, like fast language model from Unsloth, and then let's specify some of the parameters like what should be the sequence length, and then we are enabling 4-bit quantization model, and then the model which we are selecting is Unsloth's own Llama 3 8 billion, and then we are specifying our model, these parameters and the tokenizer. So let's run it. And you can see that the model is being downloaded. The size is around just under 6 gig. Let's wait for it to finish. And the model and tokenizer both are downloaded. Next step, let's specify our PEFT model. Now, what this command is doing it, this is specifying the parameters which are used to fine tune a pre-trained model, which is in our case this Llama 3 model. And if you look at these parameters, the model specifies the model which we have just downloaded. R is the low rank approximation used in LoRa or low rank adaptation, and the higher value of this increases the capacity of fine tuned model but also increases the computational cost, so you can either reduce it or increase it. Then we are specifying few of the target modules that will be modified during fine tuning. These modules are responsible for processing input queries, keys, values, and output projections within the model or neural network. Then we are specifying this LoRa alpha, that is a hyperparameter that controls the strength of LoRa adaptation. A higher value means the model will be more aggressive in adapting to the new task. LoRa dropout is 0, which is optimized, and it applies to the LoRa layers, and no dropout is there at the moment. We are not specifying any bias, and then we are using this gradient checkpointing to Unsloth. So, and this is to reduce the memory usage during a training. So by setting it to Unsloth, it means that it will be more efficient and it will require less VRAM. Then we are just specifying a seed for the random number generator used in fine tuning, and then we are not using this rank stabilized LoRa or RS LoRa, which can improve stability and performance in some cases, but I think we are good here. And then we are also not specifying this configuration for loft Q, which is another fine tuning or parameter efficient fine tuning that can be used in combination with LoRa. Okay, so let me run it. Shouldn't take too long. That is done. And now let's specify our dataset. This dataset is simply from Hugging Face. You can replace it with your own dataset. Let's download it. And that is already done. It is a sort of a shrunk, shorter size dataset just to make things easier and quicker for us to show. And towards the end, we have also specified these columns which are present in dataset. Now, just because we want to customize it as per Ollama, in Ollama, we need only two columns. One is instruction and the other one is output column. But here we have four columns. So what we need to do, we will keep this instruction as is, but we need to merge the rest of the stuff into one column or instruction prompt. So also remember that these LLMs, they're all next word predictor. So we can customize the instruction to anything we like. So the good thing is that this Unsloth has its own function which we can use, which is called as import to share GPT, and they have way more detail on their GitHub repo. So what this does is that it uses merge prompt to enclose all columns in curly braces, and then it also uses optional text. For example, if the column something like p class is empty, the merging function will not show the text and skip this. And you can select every column in your dataset or just simple few. And then you can also select the output or target prediction column in the output column name. And for this dataset which we are using, the output column name will be output. So we are merging all of the um, column names into this output. So let me run it here. There you go. So it is flattening it. And you have to do this massaging almost with all of the use cases, because your own data set, your own use case will be always different. So that is done. And then you can just simply standardize it to fix up the data set. These are the built-in function from Unsloth. That is all done. And now we need to customize it into the alpaca format. And it's a very famous, very commonly used format. Alpaca one, we have instruction, input and response. So let's specify it. That is also done. Now, one thing here is that you see that we have this alpaca format has three fields, right? But our OpenAI style chatbots, which Ollama is compatible to, only uses two fields, instructions and response, as we saw earlier. And that is why we use to share GPT function to merge these columns into one. So now we have to use input for the instruction and output for the response. So in order to do that, what we need to do, we need to specify a, you know, let me first show you what the bad chat template looks like, which won't really work. So for example, if you use this is sort of a bad chat template, but so don't use it. What you need to use is this chat template. Let me quickly, sorry, not this one. My copy paste is just struggling a bit today. Let me paste it again. There you go. So you see, this is a proper chat template where we are specifying that below are some instructions, and then this is the instruction where input goes. This is a response where output goes. Again instruction and then output. So this is our chat template, and then we are applying that chat template to our dataset with the help of Unsloth. So all you need to do is to just use this, and behind the scene it uses this map function or map reduce. So that is there is to it. Okay, if you want, you can also use system prompt, and you can use uh, for the Ollama, for example. Let me show you what I mean, but that is totally optional. I'm just showing you for the purpose of learning. You can also use something like this, and because sometimes this is good for Ollama. Now if you want to use your chat template for Llama 3, which is for if you remember my other videos, we have seen this in end of turn, where if you want to use a chat system or chatbot, you will be using something like this. So up to you which one you want to use. Okay, so now that's said and done, let me show you how to do the training. Now for the training purposes, it's a very familiar trainer which I have already covered in a lot of my videos. All we are doing it here is we are importing this SFT trainer, and then some other things. We are specifying all the hyperparameters, and I already have gone into way more detail in my other videos. But all that is happening is we are specifying what should be the sequence length, what is the data set, what is the model tokenizer, how many steps to training, how many epochs will be there, what will be the learning scheduler, and then we are using optimizer as AdamW, and then some of the scheduler type, random values, and where should it put the output. So let's define it. Let's wait for it to get defined. So this is defining our SFT trainer with the help of Hugging Face, and we are only doing 60 steps to speed things up. But of course, you can simply increase these steps, you can increase these epochs, depends upon your own use case. So let's wait for it to finish. Once that's done, we are going to start the training. So trainer is configured and initialized, and now in order to start the training, you can simply run trainer.train, and it is going to train it with the help of Unsloth. Let's wait for it to see how long does it take. And you see that it is also showing a very nicely written progress bar, and ETA is just under 4 minutes. And one of the coolest thing is that you will see that as the training progresses, this loss will keep coming down. Okay, let's wait for it to finish. Okay, so the training has finished, and you can see that it took around the same time which it was projecting earlier. And if you look at the training steps, it has come down a lot. Okay, now if you want, you can do the inference with the model which we have just fine-tuned, such as what is happiness, and then it is loading the model usual structure from the transformers where it is using that. So there you go. So this is your own model which you have just fine-tuned, and it has producing the result here for your prompt. And not only that, because it is a sort of a chat bot, you can also do long conversation, something like that, where we are assigning the roles of users and the model assistant, and you can ask multiple questions like what is contentment, how much is enough, is Mount Root a mountain in Sydney. Let's see what this does. So let's run it. It says no, Mount Root is not a mountain in Sydney, it is a suburb located in Western. That is correct. So see, it is just given us a whole string of stuff. That is good. And now you can either save the model locally, or you can push it to the Hugging Face hub by using that push to hub function. But I'm just going to save it locally by using this model.save pretrain, and it has been saved with these values locally with the name of lore underscore model. You can of course name it as you like. And now in the future, if you just want to load your model back, all you need to do is to run these commands, where we are simply using the model and tokenizer from fast language model. And then this is the model name. You can change it as if you have given it a different name. And then we are simply giving it a prompt and getting the response back. So there you go. So it has returned us the response. So you can not only save it, you can reload it back as many times as you like. Next up, we are going to integrate it with Ollama. And for Ollama, we need to create a model file. That is a prerequisites for Ollama. And I have already done a detailed video as how to use model file in Ollama. So make sure to also check out that video. You won't be disappointed. It goes into way more detail as how to use that. So Unsloth also provides a very cool way of first converting the model we have just created into GGUF format with quantization of 8. So Q8 is quite fast and high resource usage, but generally acceptable. So here we are just saving the pre-trained model which we have just created into Q8. That is a default, and behind the scene they use llama.cpp, which is a Python wrapper for C++ library, which is used for inference. I have also done a lot of videos on llama.cpp too. So let me run this. So you see that it is cloning the llama.cpp, and then it is going to use that to convert it to GGUF. So let's wait for it to finish. It might take a bit of a time. So it is still cloning it, taking a bit of a time, and it says that it will take around 5 minutes. And while this runs, let me also show you my Ollama. So I'm just opening a new window. Let me deactivate my previous conda. Let me clear it. And you see that this is my Ollama already running. If you don't know how to install Ollama, please search the channel. It's very easy, very, very easy. And let me actually quickly show you how easy that is. If you go to Ollama, click on download, just run this command for Linux on your terminal and it is going to install Ollama. That's it. And for Windows, just download this exe and it is going to install it on your local system by doing next. Okay, so coming back to this one. Now, for example, you have just installed Ollama and you want to run any model. All you need to do is to do Ollama pull and it is going to download the model. I already have various models there, and if you want to run it, simply do Ollama serve. And because mine is already running, so it is already serving there, but this is a, if this is the first time you are doing, maybe just run this Ollama serve and it is going to start running this Ollama on your local system. Okay, so let's go back to our notebook. So it seems that it has done something. Let's go down, and there you go. So it has saved it here, dot slash portal in the current directory, and this is a Q8 quantization level, and these are the different quantization level it has done. And you see that it has gone into the layers and all that modules, and just save it as a GGUF format, and then it has given you its conversion there too. And also it has saved Ollama model file to model file, and I think you can also use this command to check out the format of the model file. And this is I really like about Unsloth. Otherwise you have to do this thing manually, but this creates a very nice template for your Ollama model file. And if you want to, of course, learn more about what model file is, then please check out my other video. But in a very high level, it specifies where the GGUF file is, what prompt template you are using, and if there are any hyperparameters like these ones, or the hyperparameters like temperature, top P, top K you want to specify. So now if you go to your terminal and you check out that model directory, and then if you do ls-ltr, you will see that this is your new fine-tuned model with your tensor, and this is a GGUF file, the second last one. And there you go, you have your model file ready to, and by using this model file you can create your Ollama model. So let's get out of here, let's clear the screen, and then you just need to use this command like Ollama create Unsloth model. You can name it anything you like, dot model, and then your model file. So let me run it. And as soon as we have run it, it is transferring the model data to Ollama. So let's wait for it to finish. So you can see that it has created the Ollama model successfully. And now if you do Ollama list, you will see that now your new Unsloth model is there in Ollama. And if you want to run it, simply do Ollama run Unsloth underscore model, and you can chat with it. Let's wait for it to load. There you go. Hello, what is happiness? There you go. So how cool is that? So your own model fine tune on your own data, and you can use it however you like. You can even push it to Hugging Face. You can even publish it to Ollama's website so that others would be able to use it too. And I have a separate video where I show you how to upload the model to Ollama and various other things. So that's it guys, I hope that you enjoyed it. As I said earlier, I'm going to put all the commands which I have used in my blog, and I will drop the link to it in video description. But really, hats off to Unsloth, amazing stuff. And by the way, they have various notebooks on their site which you can check out, including this one. And I have changed it a lot just to uh, purpose fit this video, but other than that, the GitHub repo is full of nuggets, and I will drop the link to it in video description too. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.